Okay, we're going to go ahead and get started. Welcome to IM1B Essentials. I think all of you guys that are in here were in here last semester as well, so nothing in here should be particularly new to you. We will go ahead and going to be some introductions. I want to just give you a little more information about the class, make sure everybody's in the correct math-based class. I do not think we will have time for this math mindset discussion here. Um, because I want to make sure we get to assignment 1 and assignment 2 so that you guys can get those in. The discussions are a little bit easier for you guys to do on your own typically. We will touch on some background knowledge, get you ready for those lessons and those assignments. Then we're going to do assignment 1 and assignment 2. Those are the two assignments that are due on Friday this week. So we will get through those. And then, of course, as always, there will be time for study hall at the end. Because this is the first week of the semester, nobody is really behind, so I'm not going to ask anybody to stay. The one thing that will be new this semester is if you are missing assignments and you're here in class, I will ask you to stay for that study hall to go ahead and complete those assignments, and then I will allow you to leave once they are done and once you're all caught up. We can also use that study hall to get ahead. So doing assignments that are coming up if you're interested in that. Okay, let's go ahead and get started. A little intro about me. You guys should all know me already because you've been here in this class with me before. So really quickly, I do still want everybody to go ahead and send me a text message now with your name and your favorite hobby. This just gets that text thread open so that we can easily communicate. So once you have that thread open, you'll be have easier access to send me a photo, send me a message if you need help with your homework or one of your performance tasks. Or even if you have a question, a small question while you're working on one of those tests, it's nice to have that easy access. I can quickly answer via a text message. With email, it might sometimes take me a little bit longer to get back to you. So go ahead right now, send me a text message. I have my phone number right here. You're going to send me a text message with your name and your favorite hobby. So favorite hobby could be playing a sport, could be listening to music, watching movies, playing music, um, lots of things, whatever you like to do in your free time. Okay, if you are just coming in, we are at this time taking a few minutes to send me a text message now with your name and your favorite hobby. My phone number is here on the screen. It's 279-272-5628. Go ahead and send me a message now with your name and your favorite hobby. I'm seeing those come through. And I'm going to save your contact to my phone. So thank you, Mariah. That's a unique one, working on cars. I haven't seen that one yet. Anime, tinkering with technology, cooking. Oh, I wish that was my hobby. I do not like cooking. I wish I did because I probably would eat a lot better. Thank you. Thank you. I will be saving your guys' numbers in my phone so that when you text me, I'll know who it is. You won't have to introduce yourself. You can just get right into your question. So I am your math intervention teacher. My goal is to help you guys build confidence, close those learning gaps, and then stay on track in your math class so that you can pass. This is a space to ask questions, practice skills, and get support. There is no pressure. If you show up and you try and you do your assignments as we do them, you will be successful here. Okay, even if math hasn't always felt easy, you can be successful in this class as long as you are showing up, asking questions when you have them, and allowing me to support you on this journey here for this semester. Thank you, Abrielle. Okay, I think from here, the only person who is not, I think we had issues. We weren't able to add a few of you. So let me double check. I think Sean and Zuhal, um, we weren't able to add you to the math-based course. And let me just double check that you're not in here. Um, yeah. So let me go ahead and give you the link, and that way you guys can add yourselves. I'm going to post it in the chat. So this way you can make sure that you are in the correct math-based course. I do have custom math-based tasks. So if you're in my course, you're going to have different tasks than someone who is in the regular IM1B course. So you do want to make sure you are in the correct course and you're not in one of those other ones. Otherwise, you're going to have different assignments than what I'm giving you. So go ahead and Sean and Zuhal, if you can click those links and add yourselves to the course. And then let me know in the chat when you are done with that so we can move on. Thank you, Sean. Thank you, Zuhal. We will keep going now. All right, so two things I wanted to just remind you of. We use this time to take control of our learning, complete our required work, and build confidence in math. When you show up consistently and you use the time well, which means you show up and you're doing the assignments with us, and then you are submitting them right after class or even during class, you will make progress and passing will be achievable. So this class doesn't have to be a stressful class for you as long as you show up to class once a week and get your work done, you will be successful. Really quickly, I wanted to just talk about your math-based assignments. This shouldn't be new. This is the same as last semester, but when you click on Buzz and you go to your assignment, it's originally going to take you to the lesson. It's going to look something like this here. When you see the lesson, you will see this button that says Adaptive Task. This is not your homework assignment. Okay, this is not your homework assignment. Do not click on that. In order to get to your homework assignment, you're going to click the button that says Assigned at the top of the screen. Okay, this is going to have all your assignments. You are not doing that adaptive task button. You are going to go to Assigned. And from there, you will see a list of assignments that looks like this one here. I have today finally finished updating all of your assignments. They should all say McPherson on them. They should say McPherson and then give you the assignment number. If you're doing assignment that does not say McPherson on it, if it does not say McPherson, you're doing the wrong assignment. Okay, it should say McPherson and then it should say the assignment and the number. And you want the assignment number to match the assignment number that you see on Buzz. Hopefully we're all clear on that. Make sure your assignment number matches what you see on Buzz, and that's going to tell you where you submit it as well. Okay, we are not going to do the math mindset discussion so that we have time to get through our assignment for the week. We're going to start with lesson 5.01, graphs and characteristics of exponential functions. Okay, so we have, before I even get started on this stuff, we have last semester talked about linear functions. Okay, we talked about linear functions, and I want to just do a quick little reminder. They always looked like a line. So you had a straight line. That's a linear function. You might also remember that we wrote them out in equations, and they were in the form of y equals mx plus b. Okay, so that is a linear function. These are what we did last semester. This semester, we're going to be talking about some exponential functions. Okay, they are similar in that we can graph them. They represent a situation. We can get data from them, but they do look different, okay? An exponential function doubles. So where a linear function increases by the same amount each unit, an exponential function is going to double each unit. So we're going to see what that looks like. But if we looked at it as a picture in terms of cells, okay, cells are things that are make up your body. Okay, so we can say on day 0, we start with 1 cell. Then on day 1, this is going to split and form 2 cells. The next day we split and now we have 4 cells. Notice it's doubling, so we're multiplying by 2 every time. The next day we split and we have 8 cells. Who can guess how many cells we would have on the next day? You can drop it in the chat. Thank you, Mariah. That's correct. Anybody else want to take a guess? How many cells will we have on the next day? Notice we are doubling every time, so we would just have to double this and we would have 16. So we're not going to worry about this right now. But if we were to picture this as an equation similar to this y equals mx plus b situation, it would look like this. Y equals 2 to the power of x. It looks a little bit different. Notice this x is in the exponent. It's not being multiplied. It is in the exponent. This 2 tells me that we are doubling. If it was a 3, we'd be tripling. If it was a 4, we'd be quadrupling. If it was a 1, we would be staying the same every time, right? We would just be doing the same number every time. Okay. All right. So this part, I'm just going to show you. If it's not making complete sense, that's okay. I don't want you to freak out or anything. Remember, we talked about how linear equations were in the form of y equals mx plus b. There's no numbers here. This is just a formula. Okay, the formula for an exponential function looks like this. Y equals a to the power of x, or y equals a to the power of negative x. Okay, that is a formula. You're not going to see that really unless you are being asked to determine what kind of function it is. In this case, it would be an exponential. We have our x in the exponent. That's what makes it an exponential function. Okay, a can be any number bigger than 1. That means a is never going to be 0. It's never going to be a negative number, and it's never going to be a fraction less than 1. So it wouldn't be 1/2. It would be something bigger than 1, okay? Let's see. So a, or if you have this y equals a to the x, that would be used to represent quantities that increase over time. Okay, notice that's exponential growth. A to the power of negative x, notice it's negative here, would be used to represent quantities that decrease over time. So that would be decay. So it's getting smaller. Okay, the next important term you need to remember is the term asymptote. Asymptote. Okay, an asymptote is a line the graph gets closer and closer to but never touches. So this is what an exponential graph looks like. Okay, it's going to be a curved line just like this one here. With exponentials, you always are going to have an asymptote. That is the line that your graph gets closer and closer to, but it never touches. In this case, it's right here on the x-axis. Okay, this curve is going to get closer and closer and closer to that orange line, but it's never going to actually touch it. It's just going to get closer and closer and closer. Okay, it never touches it. It never crosses it. It just keeps getting really, 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 really close. Okay, that is an asymptote. Important for you to remember that term. Okay, really quickly, we're going to do a little exponent review because it's been a while, I'm sure, since you guys have seen these. When you have positive exponents, this is how you do it. If you have 2 to the power of 3, that means you're going to take the base and you're going to multiply it by itself 3 times. 1, 2, 3. The exponent tells you how many times you multiply it. The base tells you the number that's being multiplied. So another example would be 4 squared. In that case, you have the number 4 and you're going to multiply it by itself. You're going to have 2 4s being multiplied because there's a 2 there, which would be 16. Okay, that is for positive exponents. Next, we have negative exponents. Okay, with negative exponents, these are the ones that get a little bit trickier because number one, it's not very intuitive. It doesn't quite make sense. I understand that. And for two, it's a fraction, and a lot of us don't like fractions, okay? You're not alone if you don't like fractions. I'm with you. I didn't like them when I was in high school either. It took me a long, 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 long time before I got comfortable with them. But I'm here with you. I'm going to work through them with you. It'll be okay. All right, so when you have a negative exponent, it means you're going to take the reciprocal, which means we flip it, and we're going to put it under a 1. Okay, so a to the power of a negative n is going to be 1 over a to the positive n. So if we look at the example, we've got 2 to the power of negative 3. Okay, so we take that and we put it under a 1 and the exponent becomes positive. And then here they kind of skipped a step. So I'm going to say, then we had 1 over 2 times 2 times 2, which is what gave us that 1 over 8. So if we had 4 to the power of negative 2, we would first put it under under a 1, put it in the denominator, make that exponent positive. So we had 1 over 4 squared. Okay, so that's the part that's kind of wild. You might not think to do that, but we'll work through it. And then you do 1 over 4 squared when it's 4 times 4. So that's 1 over, and then 4 times 4 is 16. So it would be 1 over 16. Okay, key reminder for you is that negative exponents do not make numbers negative. Okay, it's not going to turn the number negative. It's just going to move the base to the denominator. Okay, we're going to go ahead and get started on math-based task 1, number 1. So go ahead and get into math-based and go to McPherson, Unit 1, or sorry, it's Unit 5, Assignment 1. And when you get there, I'd like you to let me know in the chat by saying ready. Thank you, Teresa. Thank you, Brianna. Thank you, Samaya. Thank you, Mariah. And is anyone having issues finding the task? Okay, so you're going to go into, you can go to Buzz or you can go straight to MathSpace. Have you gone into MathSpace before? Okay, go to your MathSpace account. Let me know when you're there. Okay, perfect. All right, we're going to go ahead and get started. So number one says fill in the missing coordinate in each ordered pair so that the pair is a solution to the equation y equals 5 to the power of x. Okay, so keep in mind every ordered pair, the first is the x, the second is the y. Okay, so looking at 1a, it's giving you your x value and you need to find your y value. Okay, so what you're going to do is you're going to plug that x value into the equation we have. So it's y equals 5, and then instead of x, we're going to put the number that they gave us, which was 2. So y equals 5 squared, which means 5 times 5, and 5 times 5 is 25. So we know when x is 2, y is going to be 25. So that is your first answer there. Now, looking at 1b, we are needing to know what x is, and they gave us the y value. So we're going to plug that 5 in for y and then see if we can figure out what x is. So we're going to have 5 equals 5 to the power of x. And for this one, we've got to use some thinking skills, okay? 5 times 5, how many times is going to give us 5? Well, if we did 2 of them, that would give us 25, which is way too much. So what would happen if we just had 1? What would happen if x was equal to 1? If we had 5 to the power of 1, that's just 5. So x has to be 1. So your answer for the second one is 1. Perfect, Mariah. Okay, now we're looking at 1C. They are giving us our x, and we need to figure out what is our y. So we're going to have y equals 5 to the power of -1. Now remember, when we have that negative exponent, it doesn't turn our number negative. It just moves everything to the bottom of that fraction. Okay, so we're going to have y equals 1 over 5 to the power of 1. What did we say 5 to the power of 1 was? Yes. So we know that y equals 1 over 5. So in here, 1 over 5. And if you need help inputting that, you can just type 1/5 and it should turn it into a fraction for you. Okay, and the last one, I just want to clarify before I get started on it. You guys do have 1 over 25 here, right? For your y value, you're given 1 over 25. Okay. All right, so we're given our y value is 1 over 25 equals 5 to the power of x. Okay, so I'm seeing this and I'm seeing it has to equal a fraction, which is telling me that that exponent needs to be negative because it needs to create a fraction, right? So if that exponent needs to be negative, now I need to think about, okay, from 5, how am I going to get 25? What am I going to have to do with that 5? Do I do one of them? Do I do 2 5s, 3 5s, 4 5s? How many 5s multiplied together would give me 25? 5 times 5 equals 25, right? So how many 5s did we multiply together? 2, right? 5 times 5 equals 25. And we had 1, 2 of them. So 5 squared equals 25. So that tells me that this, we know it's negative, and it's a negative 2. So x equals negative 2. So in here, you're going to write negative 2. Okay, moving on to number 2. Okay, we are given the graph of the equation y equals 2x. Now, 2a says, what can we say about the value of y, okay, the y value of every point on the graph? So remember, the y value tells you how high it is, right? So looking at this graph, we're going to have an asymptote here on the x-axis, which means what? We're never going to touch that x-axis, right? We're always going to stay above it. So thinking about the y values, would the y value ever be 0? Would it ever be on this line? Nope, it's always going to be above it, right? So let's look at these options. It says the y value of most points on the graph is greater than 1. So that's saying the y value of most points on the graph, my pen is not working, is bigger than this. Okay, and that one seems like it might be true because if you look, it's like, oh, well, this is going to keep going on and on forever up this way, and this one's just going to end eventually. But in reality, it's going to keep going infinitely, both directions. So that one is not true. The second one says the y value of most points on the graph is positive, and the y value at one point is 0. Okay, that second part there, that y value at one point is 0, we are never going to be 0. We're always going to be above it. So that one is not true. The third one, the y value of every point on the graph is positive. That one is true because we're always going to be above 0, which means we're always going to be positive. So that one is your correct answer there. The last one says the y value of every point on the graph is an integer. Also not true because we do have some fractions in there. Okay, we have 1.73 on there somewhere. Okay, looking at B, as the value of x gets large in the negative direction, okay, the value of x gets large in the negative direction. So that means we're going this way. As we go that way, what do the y values approach but never quite reach? Perfect, Mariah. That's right. Okay, they're getting really, really close to 0, but they're never going to reach it. Okay, 2C, what do we call the horizontal line where y equals 0, which y equals 2 to the x gets closer and closer but never intersects? What do we call that line? Starts with an A. Yes, Mariah, perfect. It is the asymptote, the horizontal asymptote of the curve. Okay, the x-intercept is where you cross the x-axis, and the y-intercept is where you cross the y-axis. All right, number 3. Okay, the graph of y equals 2x is displayed here. Okay, 3a says, what is the y-intercept of this graph? Okay, the y-intercept is the point where you cross the y-axis. This is our y-axis, right? Okay, the point where we cross is right here. What is the value there? We know this is 2, this is 4, so we're going up by 2's every time, so that has to be 1. Okay, so y equals 1. Okay, 3b. Does the graph have an x-intercept? Well, the x-intercept would be where we cross the x-axis, and I'm going to tell you this graph looks like it's crossing, but it's not. Okay, it's just getting really, 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 really close because what do we have there? We have an asymptote there. Okay, so it's getting really, really close, but no, there is no x-intercept. Okay, which single option below gives us the graph's domain? You might need a little reminder what domain and range are. Okay, domain and range go together. Domain tells us from left to right, are there any boundaries? Are there limits to where we're going? So if we're looking left to right on that graph, is it ever going to stop in either direction from left to right? The answer is no. It's going to just keep going on and on and on forever. So these 3 options give us a boundary. They say we have a boundary. All real x says there are no boundaries. And that is the appropriate answer for that one. Now, when we look at the range, range tells us up and down. When I think of range, I think of mountain range. And that's how I remember that it's up and down, because a mountain range goes up and down and up and down. So range, mountain range, up and down. Domain is the other one. Okay, so when you think about the range, it's saying, are there any boundaries up or down on this one? Are there any boundaries going up? Nope, it's going to keep going up and up. Are there any boundaries on the bottom? Yes, at that asymptote, right? So we know that y is going to be bigger than the asymptote or lower? Bigger, right? It's always going to be bigger. So I'm looking at these and I see this one says bigger and this one says bigger. Okay, remember that alligator mouth opens to what's bigger. Okay, and this one says bigger than or equal to. And we know we're never going to touch that asymptote. So it's not equal to, it is y is greater than 0. Okay, 3e, I believe you guys have a different number than I have here. Is it 5? I feel like it was 5. For 3e, I think it says x equals 5 for you guys. Can somebody confirm that for me? Okay, so I'm guessing that that is right. We have x equals 5 for 3e. So if our equation is y equals 2 to the power of x, we're going to plug that 5 in for the x. So we're going to have y equals 2 to the 5th. And that is 2 times 2 times 2 times 2 times 2. 5 2's. I like to do them. I break it up into the first two. 2 times 2, that's 4. So then I'm going to copy the rest down. Then I'm going to do these two. That's 8. Then I do these two. That's 16 times 2. And now we can do that last one. We get 32. So y equals 32. And I think that this one was different too. What do you guys have for 3F? Y equals, is it 128? I want to say it was 128. Okay, so it's giving us our y value. It's saying 128 equals 2 to the power of x. And we need to figure out how many 2's is going to give us 128. So we already know that 5 2's gave us how much? 32, right? So we had 5 2's gave us 32. So if we add another one, then we're going to have 6 2's. What's that going to be? 64. Add another one. Let's do 7 2's. And that's going to give us 128. And that's what we were looking for. So it was 7. So x equals 7. All right, one more. One more on this task. Okay, so it says complete the table of values. We have y equals 2 to the power of x. So we've got -2. So this is 2 to the power of -2, which means we've got 1 over 2 squared, which is 1 over 4. That first box. And then we're going to have 1 over 2 to the first, which is just 2. Anything to the power of 0 is just 1. And then we're going to have 2 to the power of 1, which is 2. 2 to the power of 2, which is 4. 2 to the power of 3, which is 8. 2 to the power of 5, which is 32. And then we've got 2 to the power of 10. So if you can't do this one in your head, which I can't do it in my head either, you can use during the practice test or the test, you can use a calculator. I'm going to show you how to use the math solver. Okay, you're going to do 2. And then if you hit this little button on the top left, it'll allow you to put the exponent in. And we're going 2 to the 10th. Oh, what was that? Okay. And that gives us our answer. It is 1024. So this answer here is 1024. Okay, 4B is y to the 2x, an increasing function or a decreasing function. As we go up, it's going up, right? It's getting bigger. That means it's increasing. How would you describe the rate of increase of the function? As x increases, the function increases at a faster and faster rate. Yes, it's not increasing at a constant rate, right? If it was going at a constant rate, we would just be going up by 2 every time. But we're doubling every time. So it's going up faster and faster. Okay, 4D, what is the domain? Remember, domain is left to right. There is no boundaries, okay? Your domain can be anything, so it's all real X. And then for E, what is the range? Again, we have that asymptote where Y equals 0, so we know Y has to be greater than 0. Y is greater than 0. And for most of these exponential functions you see, your range is always going to be Y is greater than 0 for right now. Once you guys get up into higher level maths, it might change, but for now, your asymptote will typically be right at the x-axis. Okay, you guys can take your screenshot, save it to your desktop so that you can easily upload it to Buzz. Take the screenshot of your score, make sure I can see the title in there and your score. And then we will quickly go into our next assignment. We still have about 15 minutes. Hopefully we can get everything done before then. We might go a little bit over today, but just so you guys know, there will also be days where the tasks are short and we're shorter than an hour, okay? It's going to be kind of fluctuating depending on the week. Okay. Lesson 5.5, we are comparing those linear and exponential. So at the beginning of the lesson, I talked about how linear functions were the straight lines. Today we learned about exponential, which are the curves. Okay, here are the differences. We're going to be looking at linear next to exponential and figuring out what's the difference between the two. Okay, linear change by a constant amount. That means you're like adding 2 every time. Okay, you're going up by 2. Exponential change by a constant factor, which means we're multiplying by 2 every time. It could also be multiplying by 3, multiplying by 4, 5, whatever it is. But just keep in mind, exponential functions, we are multiplying every time. Linear, we're adding or subtracting every time. If you want to take a screenshot of this slide and save it to your desktop, that might be helpful as well. Okay. Linear equations are always in the form y equals mx plus b. Exponential functions are going to be in the form y equals a to the power of x or y equals a to the power of negative x. Okay, linear functions, the graph is a straight line, just like pictured. And then exponential functions, the graph is a curve with an asymptote. And remember that asymptote usually is right below it. Here's your asymptote. I ran out of room. Okay. All right. We're going to start that task. So go ahead and open up math-based task number 2. So we're looking for assignment 2. Make sure it has the McPherson on it so you know it's the right one. McPherson, Unit 5, Assignment 2. And let me know in the chat when you guys are ready to go. Thank you, Alexis. Thank you, Mariah, Samaya, Teresa. Thank you, guys. All right. If you're having issues, let me know in the chat as well, and I can help you. I'm going to go ahead and get started. Okay, number one, a linear function and an exponential function have been graphed and drawn on the same coordinate plane. So looking at these, I can see this one here is the linear. I can see this one here with the curve is the exponential. Okay, the straight one is the linear curve or the linear graph, and the curved one is the exponential graph. Okay, so now we can answer the questions. 1A, over any 1 unit interval of x, by what constant amount does the linear function grow? Okay, this is asking about the linear one. So if we look over 1 unit, so let's just look from 0 to 1. How much did we grow? So this is 1. We went up to 5. So we grew by 5 units, right? So the answer for that first one, 5 units. 1B says over any 1 unit interval of x, by what constant ratio does the exponential function go? Okay, so now we're looking at the exponential, and the easiest way to figure it out for exponential is look, what are we at when we are at 1? When we're at 1, we're up at 5, right? And then when we hit 2, we go up to, where's 2? Oh, sorry, I looked at the wrong part, the wrong one. Let's erase that. When we are at 1, that exponential function is right here. The exponential function is at 3. Do you guys see that? Okay. And then when you look at 2, your exponential function is at, oops, I'm doing the wrong part again. The exponential, why is that not working? Okay. When you look at 2, the exponential function is right there. It looks like it is at 9. So how do we get from 3 to 9? What do we need to multiply by to get from 3 to 9? 3 times 3, right? So we are increasing by multiples of 3. Okay, 1C says, would it be correct to state that the linear function always produces greater values than the exponential function? No, because sometimes the exponential one is going to produce greater values, right? So maybe in the beginning here, the linear is, if you look at this period right here, where the linear is greater than the exponential, that's the only part where the linear is higher. If you look over here, anywhere over here, this one is going to be greater. So this answer here would be no. And then 1D says, as x approaches infinity, so as we go this way, which function increases more rapidly? And rapidly means quicker. Which one's going up faster? The linear or the exponential? Correct. It is the exponential function. That one's going up much faster. Okay, task number 2. Matt and Elizabeth are saving money using different strategies. The amount each has saved after each month is given by the table of values and the plotted points. So here we have Elizabeth's savings, and then here we have Matt's savings. So we've got 2 different forms. They're both saving money. So let's see what's happening. If we look at Elizabeth's savings, month 1, she's got $6. Month 2, she's got $36. And then she's got 216. So we're not increasing by the same amount every time. It looks like we're being multiplied every time, right? I think we're multiplying by 6 both times, right? So this one's going to be exponential. If we look at Matt's savings here, we're going, I can look at this right now. This is a straight line. So this one's going to be linear, right? And it looks like he started with, I don't know, maybe $75. And then the next month he's saved about 150-ish. Okay, it looks like he's saving about $75 a month. Okay, 2A. If each person continues their pattern, who will be the first to exceed savings of $700? It looks like we're going to go one more time, times 6, and we'll be at 6 something. So I'm thinking it's going to be Elizabeth is going to exceed it way before Matt will. And then logically thinking, whose savings model is the most realistic in the long run? So if you were working, which one would make the more sense? Do you think you're going to be multiplying your savings by 6 every month? Probably not. Yes, sorry, Mariah, I just saw your question in the chat. Okay. So yes, Matt's model is going to be more realistic because you're not going to be multiplying your savings by 6 every month forever. That would be really, really nice, but not very realistic. Okay. Task number 3, and then this one's a long one, and then the next one, number 4, is really short. So I think we'll be good and be able to finish before 2. Okay, consider the functions f of x equals 3x and g of x equals 3 to the power of x. Complete the table of values for each function. Okay, so looking at f of x, this is a linear function. So we're doing 3 times 0, which is 0. And then 3 times 1, going to give us 3. 3 times 2, going to give us 6. 3 times 3, which will give us 9. And then 3 times 4, which would give us 12. Okay, now we're doing g of x. We have that exponent. So we've got 3 to the power of 0, which is 1. Anything to the power of 0 is 1. 3 to the power of 1, which is 3. 3 to the power of 2, which is 9. And now, if you think about the pattern, we're just multiplying by 3 every time, right? So what's 9 times 3? 27. And then 27 times 3 is 81. We also could have followed the pattern on the linear function as well and just added 3 every time. Okay, we are graphing now, so I'm going to quickly, let me pull it up first. I'd like to share my screen so I can show you guys how to graph this because I think it can get a little complicated. Okay, allow, I want this one. Okay, so we're doing this class. Let's go look at the task. Unit 5, assignment 2. Okay. And we're on number 3. Okay, darn it. I already had to do it. Okay, so for this one, I would start by doing the linear function. Take 1 point from that linear function, and we're just going to use these first 2 points. We'll use 0, 0, and 1, 3. So grab one of the points that's on your straight line and move it to 0, 0. And then grab another point and move it to 1, 3, which is right here. Then you have your linear one done. And then for the exponential function, you're going to grab your point that's on that asymptote. Notice they have this dashed line. Grab the point it's probably somewhere around here on the y-axis. And you're going to pull that down to 0 so that your dashed line is right along the 0. And then grab the other point that's on your curved line and move it to 2, 9. Unfortunately, it wouldn't let me do it again, so I couldn't show you. Are we able to get that? Good? Okay. All right. Then we can go back to the screen. Wait, I need to stop the share here. And we are now sharing here. Yes, okay. All right, so now we're doing 3C. It says for every 1 unit increase in the x, the value of f of x increased by, well, how much did we increase by every time? 3. And then for the exponential one, we multiplied by 3 every time. So we were increasing by a factor of 3. Okay, 3D says, for where x is greater than or equal to 2, which function increases at a faster rate? So here's where x is 2. So if we look at this, and we look at this side of the graph, which one is increasing faster? The exponential, correct. And then 3E says find the following function values, f of 8 and g of 8. So for f of 8, we've got 3 times 8, which is 24. So this first one is going to be 24. And then g of 8 is 3 to the power of 8, which again, I'm not doing that in my head. So we'll go here. We'll do our math solver. We're going to have 3 exponent 8. And it's 65, 61. And then 3F, Rosie wants to model a quantity that increases at an increasing rate. Which function is most appropriate? Going to be the exponential again. Okay, the linear function is going to increase at a constant rate. Exponentials increase at an increasing rate. So the linear is going to increase, but at a constant. It would be at a constant rate. Okay. All right. Last question. And then we are all done. Yay. Okay, which type of function is shown in the graph below? Is it linear? Is it a straight line? No. Is it a square root? You guys don't even know what a square root looks like yet. So no. Is it an absolute value? You also don't know what an absolute value looks like. So no. It is exponential. Okay. Any other questions, Alexis? I will go back for you. I want to make sure there's no other questions anyone else has. Otherwise, you guys are free to go. Thank you so much for showing up. Remember, you can come any day, Monday, Tuesday, or Wednesday at 1 o'clock. Bye, Samaya. See you next week. Bye, Zuhal. Thank you. Okay. Is this the one you need, Alexis? Bye, Mariah. Bye, Abrielle. See you next week. Okay. And this one?